Okay, so good afternoon, everyone. Warm welcome to everyone, all attendees on this module, Energy Efficiency, which is organized by the BS Group. My name is Apostolos Poulovassilis, and it's a great honor and pleasure for me to be moderating this excellent panel of experts today. And I would like to give a big thank you to the BS Group and all the BS team for this great initiative. Also, thank you to the sponsors of the event, which are OCEANKING Trading SA, Yaskawa, Environmental Energy, The Switch, and Mecklenburger Metallguss GmbH. So I'd like to begin, first of all, by going through the agenda for today. I will be starting off with a short introduction of our subject on energy efficiency. And I'm going to be aiming to address some of the key points which our speakers today will be analyzing, of course, in more detail. Then our first panelist for today will be Mr. Panos Theodossopoulos, who is the Chief Digital Officer, CDO of OCEANKING Technical and Trading SA, who will be covering energy efficiency improvements through a combination of design measures and digitalization solutions to satisfy the new regulations. I must say here, after the end of Mr. Theodossopoulos' presentation, you will also have the opportunity to pose some questions to him. We have a 5-minute slot right after his presentation, which will look at Q&A only for that presentation. Then we will be continuing with Mr. Asbjørn Halsebakke, who is the Manager of Technical Solutions Marine, Yaskawa, Environmental Energy, The Switch, who will be addressing how can DC compete with medium voltage MV systems on board. And again, there'll be a Q&A part only with Mr. Halsebakke at the end of his presentation. We will then proceed with Mr. Lars Greitsch, Managing Director, Head of Research and Innovation, MMG, Mecklenburger Metallguss GmbH, who will be addressing the modern ship propeller and its digital twin. And last but not least, Mr. Nicholas Vaporis, who is the Chief Technical Officer of Capital Ship Management Corporation, who will be covering the energy efficiency innovation portfolio for new buildings. And he will also take questions at the end of his session. So, some administrative arrangements, as I've said just now, you have the opportunity of posing questions both via Q&A tabs to the panelists, for those of who have chosen that option. But otherwise, you can wait for the end of all the presentations and we will have a final Q&A session at that time. So I think we can probably start with my introduction now. And I really wanted to say, just to put us in the context of what we're going to be talking about today, is basically, we are looking at a very strange period, I would say. We're trying to navigate out of the global pandemic, which unfortunately and tragically has been part of our lives for nearly 18 months now. But I think we can say there is some increased optimism as the vaccination program is being rolled out globally. However, I can say that the challenges facing our industry, facing the global shipping industry, they remain as valid as ever. So in terms of decarbonization, which we can say is a megatrend, and with the IMO greenhouse gas strategy towards 2050, our industry has set the goal to reduce carbon intensity by 40% within the next decade, up to 2030, and by 50% in total up to 2050. Now, this greenhouse gas strategy was approved by the IMO in 2018, and the reduction rates are related to the baseline of 2008. So quite challenging targets, and I would say short-term, mid-term, and long-term measures are therefore necessary to achieve those goals. Now, the short-term measures, they are meant to be set in force by 2023. Different measures are being considered and widely discussed, and in fact, during the last MEPC 75 in November 2020, the IMO approved the amendments to MARPOL ANNEX 6, introducing an energy efficiency design index for existing ships, the EEXI, for the first time actually addressing energy efficiency for existing ships. Now, subject to its adoption at MEPC 76 next week, actually, the requirements will enter the force in 2023. Now, the EEXI is going to be applicable for all vessels, That's above 400 gross tons, which come under MARPOL. And the guidelines and calculations, surveys, verifications of the EEXI are going to be following and finalized at this next MEPC meeting. Nevertheless, as the EEXI is the extension for existing ships of the new building related EEDI, Existing Ships Design Index, most of the procedures will be the same as for the EEDI, with some adaptations regarding what is agreed to be maybe limited access to design data for some of the ships. As I said, for the first time, existing ships are coming into the energy efficiency equation, and it will be good to take some of the learnings from the new buildings, which we've applied the EEDI since 2013 to the existing fleet. So I would say the efficiency standard that existing ships are now being asked to comply with through the EEXI roughly equate to phase 2 of the EEDI, which has been enforced since 2020. Very quickly, the EEXI is determined by the CO2 emissions per ton mile. So the two largest factors, I would say, in the calculation for any ship are its installed power, first of all, but also the cargo carrying capacity in the second instance. It's going to be a simple one-off pass or fail to be taken at the first annual or special survey after January 2023. And at the surveys, the ship's efficiencies are going to be compared against the EEXI benchmark, which is set by the IMO. If the vessels pass, then the owners will get the International Energy Efficiency Certificate and can trade on. If they fail, then they will have to make some modifications, some way of upgrading efficiency, or otherwise leave the market. So the big question is, how much of the existing fleet is this going to be affecting? Some analysis carried out by class societies indicate that even maybe 60 to 70% of bulk carriers and tankers are going to have challenges in complying with the EEXI, particularly the larger ships. So what we're going to be discussing today essentially is some different methods or options for ships in order to be able to comply with the new standards, whereby ship owners first of all need to assess where their ships stand relative to the requirements and the targets, and by how much they will need to adapt in order to meet the required standards. But of course, from a commercial perspective, I would say energy efficiency is equally important, and charterers will for sure show preference to those vessels that are more fuel efficient, but also meeting their speed consumption profiles. So in practice, there is a limit to how much one can optimize one's operations, but how much you can reduce speed is one thing, and then we have to start thinking about how you adopt energy efficiency technology and retrofits as well. In terms of technology, which again, we're going to be looking at various options today. I would say they exist in various stages of deployment, which can be used by ships to comply. But I would say characteristically, as one ship owner said to me recently, it's probably wise not to be one of the first to try out new technology because history has shown that you're going to get burnt. So nevertheless, time is running out for owners that need to decide on what to invest in order to comply with the requirements, but also with the commercial, let's say, obligations. But if we are to meet and indeed exceed the IMO targets, the industry needs to come together to develop the necessary solutions that serve the sector's needs well beyond just complying, but also ensure that it's a fit for purpose, operationally sound, as well as usable by the ship's crew. And this is where crew competence and skills come in, but this, I would say, is a topic for another webinar. This is going to mean exploring innovative energy-saving equipment, future fuels, the associated infrastructure, funding, and new technology to support those who want to maintain their competitive edge in the market, while also serving the environment that we work in. So I think that's probably enough from me for the moment. I would say let's immediately go into the panel presentations, where we will see some of these solutions in practice. So, as I said, first on today is Mr. Panos Theodossopoulos. If you could please put up your presentation, and the floor is yours.
Thank you, Mr. Poulovassilis. Thank you, Apostolos. Let me share my screen. Due to a technical issue, I need to share my whole screen, so give me a second. I hope you can now see in full screen mode my PowerPoint slides. So, hello everybody, good afternoon. My name is Panos Theodossopoulos. I'm the Chief Digital Officer at OCEANKING. And it's my pleasure and honor to be presenting today our proposal for the energy efficiency improvements that one can achieve through a combination of design measures and operational digital solutions in order to satisfy the new regulations. Now, I guess we all agree that historically, or more specific, shipping, or more specifically ship owners, have always been operating on the balance between the regulatory framework and their commercial interests. This is, of course, still the case, and we see here some of the most dominant items relevant to the two sides of the scale: the 2030 and 2050 decarbonization milestones, and more so the regulations that are coming to effect in the next 3 to 5 years, in conjunction with the other non-IMO-driven guidelines like the EU MRV and others, are top of mind when it comes to the regulatory framework. On the other hand, COVID and post-COVID market and global economy trends, together with new stricter measures of bank financing and environmental, social, and corporate governance practices, are affecting decisions, revenues, and profits. One could argue that now, in fact, more than ever before, it is technology that has the power to balance the two, often opposing forces, in the most optimum way. Now, shipping is facing, as you rightly pointed out in the introduction, a big challenge on the journey to 2050, with the ultimate goal, even beyond that, to practically reach a zero carbon operation. During the MEPC 75 at the end of last year, the Energy Efficiency Index for existing ships, EEXI, and the Carbon Intensity Indicator, CII, were introduced. In terms of compliance dates, as we can see on the slide, from 1st January 23, the EEXI will be enforced, subject to adoption, of course, by MEPC 76 in just a few days from now. For the CII, the compliance dates follow different, more complicated pattern, since we have to deal with vessel rating systems as well in this case. According to these dates, the International Energy Efficiency Certificate will be issued, which will allow the vessel to continue trading. Both the EEXI and CII fall under the MARPOL ANNEX 6 regulations, where the EEXI is a technical measure affecting the design carbon intensity, and the CII is an operational measure affecting the operational carbon intensity. Now, the EEXI, as Apostolos mentioned in the introduction, has the same formula with the EEDI, the main difference lying in the required value. CII is slightly more complicated and follows a trajectory pattern of compliance, as the subject measure is based on an annual improvement of this index. In general, we can say that EEXI is a technical measure only now required for existing vessels, and various technical measures should be required in order to achieve compliance. CII, on the other side, is an operational measure and depends on vessel performance and on efficient voyage execution. What is linking the two are the energy efficiency technologies, which we will have the chance to assess and describe today, to be one of the solutions also recommended by IMO, as we can see on this slide. This is because if you want to close the gap and go closer to the required EEXI, energy efficiency technologies can't be part of the solution. In closing, I would say that an easy way to remember all this complexity, if you like, is that EEXI is all about the vessel, whereas CII is all about the voyage. So correspondingly, the factors affecting the two, or if you like, optimizing the two, are important in the two cases. Now, OCEANKING, with 32 years of presence serving and assisting the Greek ship owners with technology solutions and products, has already formed a market proposal for both of these issues. On the EEXI side, we're working together with our partner Wärtsilä Propulsion, introducing solutions improving the efficiency downstream of the propeller, others linked to the propeller itself, and finally, wind assistant propulsion and air lubrication systems as additional means to improve vessel efficiency. Moving to the CII side, we have a portfolio of digitalization solutions achieved through best-of-breed partnerships, optimizing the operation of the voyage at the vessel as well as at the engine and machinery levels. Now, if we look a bit deeper in EEXI, as said, with our partner Wärtsilä Propulsion, we're proposing an ecosystem really of solutions and synergies as a way to increase vessels' efficiency while reducing fuel consumption. So apart from the propulsion system itself, there's a large number of different technologies available to improve this efficiency. On the left-hand side of this schematic, you can see we have devices which improve the efficiency downstream of the propeller, like gate rudder and others. In the middle, we have improvements linked to the propeller itself. And lastly, on the right-hand side, we have technologies like, as I mentioned, the wind-assisted propulsion and air lubrication systems as additional means to improve efficiency of the vessel. Propulsion energy-saving devices overall can be a strong part of the solution as they increase the efficiency, but are also reliable and have a short payback period, factors which are also very important in today's increasingly competitive shipping environment. On the CII side, one could rely on a number of digitalization solutions available to optimize the voyage operations, starting from the overall energy efficiency, or as some people call it, vessel and fleet performance optimization. Here we work together with our partners Hoppe for the core sensors needed, as well as the data acquisition system, in order to collect the high frequency data, which when fed to artificial intelligence-based software platforms like the one from Nautilus Labs, with whom we're cooperating, offer the vessel performance modeling necessary to proceed, among others, to voyage optimization in terms of time charter equivalent, charter party monitoring, estimated time of arrival optimization, weather routing, and others. In addition, a side benefit is that all needed reporting is also automatically produced once systems like that are deployed across the fleet. In addition, through digitalization solutions at the engine level, one can also achieve optimum engine operation, which, apart from reducing fuel consumption, also offers reduced downtime operation. For this, we're resellers of the ABB Tecomar Expert software system. Finally, one can go down to the monitoring of the health of all rotating machinery on board through a system like the one we're working with from HAT Analytics. In closing, I would say that technology can strike a balance and at the same time serve both the regulatory framework and the commercial interest of the ship owners. For the 2030 milestone, it looks like at the vessel level for EEXI, energy-saving devices are a very attractive option, both for new builds as well as existing vessels. In terms of the operational carbon intensity index, the monitoring and optimization that is brought by the use of digitalization technologies seems to be a strong ally. Further, apart from the technical and operational consequences, I would also argue that we will see, if not a disruption, certainly a redefinition in the relation of the various market players. And I give here the example of the charters and the owners, since decisions of one might actually affect the other in a direct way. Finally, from our experience in the market, the Greek maritime community is very actively engaged in relevant discussions. And I think that once we have crystallization of the regulation, as we said, in a few days' time, we will start seeing the first relevant, tangible discussions and projects to be discussed and deployed. And with that, I would like to thank you for your time, and I remain at your disposal for any questions. So I'll stop sharing my screen.
Okay, thank you very much, Mr. Theodossopoulos. I have to apologize, I didn't give a bit of the bio for Mr. Theodossopoulos, which I will do now. As I said, he's Chief Digital Officer at OCEANKING and has worked for the past 7 years in the area of digitalization for the maritime sector in both technical and commercial aspects. And with more than 25 years of managerial experience, he has held several leadership positions in sales, business development, services and marketing in the ICT sector, both in Greece and abroad. He has also served as Director of Public Sector Sales and Director of Technology at Microsoft Lars, where he worked for 8 years, and more recently he was the CEO of Propulsion Analytics for more than 4 years, where he was also the co-founder. He holds an MSc in Mechanical Engineering from Tufts University, Boston, and a PhD in Mechanical Engineering from Imperial College, London. So I think at this stage we have a short slot of about 5 minutes for Q&A for specifically Mr. Theodossopoulos. And I see there is one already from Brian Bayliss, which I will go through now. It's how much would ship owners be willing to invest in a new technology to give them a real possibility of having this new technology installed in new buildings, or upgrading the ship to meet all the requirements, and more so, and most likely zero emissions and no fossil fuel or man-made chemical fuel, not hydrogen or ammonia. I don't know if you would like to have a look at that one, Mr. Theodossopoulos.
Well, it's the $1 million question, really, in the sense of
not there.
How much would ship owners be willing to invest? I think I can probably reverse that in my answers, saying that, for instance, the energy-saving devices technology that I presented, or similar to that, it depends on the return on investment, and we're looking at and the improvements that they provide. So if we look at the combination of some of the technologies that I presented earlier, for instance, propeller technologies, air lubrication, as well as wind-assisted propulsion, for instance, for a combination of those for a Panamax of about 80K deadweight tonnage, we're looking at a 20 to 30% potentially combined integrated reduction, which would mean a return on investment over about 3 to 4 years. So, we have to look at the relative picture rather than the absolute cost, because at the end of the day, that's what matters. And I think we're looking justifiably now at technologies that could bring a return on investment, as I said, 3 to 4 or slightly above 4 years.
Yeah, and I think you hit the nail on the head, saying that this is essentially let's say, a commercial decision. You have to look at the ROI. You have to see, what is going to be perhaps the commercial benefit, if there's going to be any premium offered by charterers to justify this additional or new technology. Bearing in mind also what I said at the beginning, that you don't want to get burnt being absolutely the first or pioneer to try something out and then maybe face both operational but also commercial difficulties further down the road. Another question from my side, and looking at your slide on energy saving devices, I noticed that you had some basically estimates there for corresponding savings. Now, I think for me this is always the important or the crucial element. What is the actual saving? Because this is something that we hear all the time from manufacturers, from designers. There's always a percentage quoted, but I think it's important to understand what is actually attainable. First of all, what is that magic percentage, let's say, and also what is the combined or aggregated effect of different technologies working together on board the vessel, and what is the net, let's say, saving that can be achieved in practice. What are your views on that?
Yeah, as I said also in the previous question, combining different technologies in the direction of energy-saving devices. Obviously, if you put 1 + 1 plus the other, it's not going to necessarily amount to the sum of all the individual elements. But nevertheless, I think one could easily look at a combined gain of 20+%. Certainly, in some studies that we have for Panamaxes, possibly a little bit less for MR tankers, so smaller size vessels. But individual elements, for instance, the gate rudder can easily flirt with numbers between 5 and 10%. But as I said, combined, you're looking at 20+% of integrated reduction. Now, again, when it comes to ROI, I mentioned before the figures for a Panamax, for an MR tanker, they would be a little bit higher, a little bit above for 4 years, but we're looking at that sort of range, more or less.
Okay, thank you very much. I think we can probably now proceed with the next panelist, who is Mr. Halsebakke, the Manager Technical Solutions Marine Yaskawa Environmental Energy with a switch. How can DC compete with a medium voltage system on board? Mr. Halsebakke, the floor is yours.
Thank you. I hope you all can hear me. Please nod if you can hear me. Thank you. So I will talk about how we can compete, how DC can compete. Let's see if we can get the presentation up. Hope you can all see my presentation also. So my name is Asbjørn Halsebakke, Manager Technical Solutions Marine. I'm come from Yaskawa Environmental Energy Division / the Switch. And we do believe that DC can compete with medium voltage solutions and comply with future environmental changes at the same time. If we look at this is a solution that we made for one of our customers. It's a big solution. We have 20 megawatt of main propulsion, 6 megawatt of thruster applications, and 20 megawatt of generators, and 6 megawatt hours with batteries. This would quite easily become a medium voltage solution if you look at the standard solution. But using our DC hubs, converting everything to DC, we can then use our electronic bus link, connect several DC hubs together into one big system, and be able to deliver the same power. The main point here is the electronic bus link. That's the one that makes this possible to do, because this one will react so fast in case of a short circuit on the cable. It will disconnect everything within 10 microseconds. That is much, much faster than any fuse or any breaker can do. And that gives us the possibility to have full control of this solution, making sure that everything is working together, that if we need to disconnect one of them, we can. And this is also DP3 approved. And we have been testing, doing a live testing on board the vessel to prove this for DNV GL, that everything is working, everything is safe. When we did that test, we connected the breaker to the cable here, closed with the short circuit, closed the breaker, and then we could see that these two disconnected, and all of the rest of the machine continued to work. With absolutely no oscillations, not on the feeder side or on the generator side. Everything was smooth running because this is so fast. So also, we can deliver the entire package so you can get all the expertise from us. We can deliver the generators. We can deliver the propulsion machines, tunnel thruster machines, DC hubs, frequency converters, all of this within this pink box, we can deliver. We are still a product supplier, but by having permanent magnet machines and permanent magnet generators from us, you know that this will work together. And how can we make sure that this will help us to meet the future regulations, the future things that will come? If you build this vessel today, it has to last at least 20 years. But with our EBL, you can introduce another DC hub with connection to a fuel cell that's run on hydrogen, ammonia, or whatever energy source that will come. Because do we really know, are we sure how things will develop in the future? I'm not sure that I fully understand what the next thing will be in 15 years. Because there are so many clever minds around working and trying to find new solutions on the problem. I'm sure that they will come up with something brilliant. But we are ready to use it. Yaskawa DC hub can't use that. So, advantages. Our DC hub, it's a plug-in, less volume, and you get rid of the AC switchboard. You can eliminate transformers or significantly downsize them. Our electronic bus links give high redundancy, increased safety, reduced fuel consumption. With a closed bus link, you can run your whole system in a much more efficient way, and you get more power on the grid. And installation flexibility. You can place DC hubs anywhere around your vessel where you have place for it. You can use that. Here you can see one of the laboratory tests that we have done. And you can see how it makes sure that we have an ultra-rapid detection and disconnection. Because this is very important. You don't only have to detect fast, but you also need to react fast. Because all of this contribute to the potential safe disconnect, potential problem, or it contributes to the safe disconnection of your fault. So what about our permanent magnet machines? It's significantly higher efficiency because you have near zero magnetic losses. It's simple, better reliability, and less maintenance than compared with a synchronous machine. Space saving, and especially in low-speed application, and it enhanced drivetrain dynamics. Here you can see a conventional rotor. Then you can compare it with our rotor. So here you can see it's much more simple solution, and it has much lower inertia. So the results. You get a low voltage installation with superior reliability and the flexibility to run on any future power source. It's future flexible. So just a bit about the references. What have we done? We are working very close with VTech and Wärtsilä and Berg Propulsion Caterpillar. We have more than 1,300 drives and 100 machines delivered for marine application worldwide. Who are we? Yaskawa Environmental Energy. We are about 200 employees. Our main focus is on wind, marine, and turbo products. And we were founded in 2006 after a merger of Rotatec, Verteco, and Utility. In 2004, Yaskawa acquired the Switch in Finland, and in 2016, the Switch acquired Wärtsilä Norway-based marine power drive business. And in 2018, we became Yaskawa Environmental Energy. If we focus on the marine, our products allow vessel operators to make sure that we have lower emissions, save fuel, and we are future flexible. With the electronic bus link, the electronic DC breaker, and the DC solutions. Also with the direct drive electric propulsion and inline shaft generator solution. Other marine applications are LNZ propulsors and auxiliary generators. So, finally, conclusion. DC hub competes easily with conventional medium voltage AC solution. That gives the owners the possibility to have a much easier solution, lower voltage, reduced risk, and it's also easier to recruit personnel. The electronic bus link allows you to connect several DC hubs in a ring configuration with higher redundancy, and you can disconnect any possible fault. There are more than 1,300 marine drives and 100 marine permanent magnet machines in operation. We have proven experience with our permanent magnet machines and the marine drives. And I think one of the most important things, it's future flexible, because we don't know what's going to happen. Did we understand 15 years ago how important batteries would be for us? I did not. If you did, I hope you invested a lot in shares with battery suppliers. But we need to be prepared. I talked with a ship owner a couple of years ago, and he said one of the most important things is that he needs to be ready to change his vessel in the lifetime of the vessel. So, thank you for listening to me. Please contact me to find out more, and also sign up for our marine blog to get more interesting information from my colleagues or from myself. I'm really looking forward to hearing from you soon.
Okay, thank you, Mr. Halsebakke. Again, I'll just give a quick bio for yourself. Being the manager of technical solutions at Marine Yaskawa and Environmental Energy, the Switch in Norway. He is leading his team in engineering marine drive solutions, frequency converters, and rotating machinery, which are in use today with the utmost reliability on vessels throughout the world. And before joining Yaskawa Environmental Energy, formerly Wärtsilä Norway AS Drives Division, Mr. Halsebakke worked for Aker Kværner Elektro AS in Norway to develop frequency drives and perform sea trials and commissioning. He graduated from Narvik University College with a Master of Science in Electrical Engineering, and also attended the University of Bergen, where he studied elementary physics and mathematics. So, without any further delay, question from me. You mentioned some of the, let's say, the numbers and regarding the application, both DC solutions and permanent magnet machines. But could you give us a bit more detail on what types of ships the profile of their trading patterns, etc., that they have been installed in? Is that possible?
Oh, it's quite many different vessels and application. But I think one of the most important thing we could say is that is the DC hub answer for all vessels? And believe it or not, I would say no, it's not. If you have a vessel going with container from A to B, then yeah, you can benefit quite a lot with using our shaft generator applications. But with the DC hub, not so much. If it's a ferry, a passenger ferry, fast ferry, offshore vessels that has a lot of maneuvering, DC hub it's a really good solution, and there we can see that's where we have most of our deliveries. I don't know if that answered your question, but
yeah, I mean, I think you're quite correct, and I think no one can predict the future, as you said. You don't have a crystal ball, but I think what is becoming clearer is that there is not going to be one size fits all.
Yeah,
there are going to be different solutions depending on the circumstances, the types of ships, the trading patterns, the profile, etc., etc. So it's going to become a very difficult, let's say, decision making for any ship owner in order to get it right. And I liked your term, the future flexible, because this is absolutely what every owner is trying to do. But doing it in practice is a challenge.
Yeah, absolutely. But also when I talk with ship owners today, some ship owners, they are saying, the only thing I'm certain about, I have to change my vessel. That's the only thing that's for sure. If it's going to be with fuel cell, if it's going to be a new engine, I don't know, but I have to change it. So then to be future flexible, we believe it's very important.
Yeah, absolutely. And because this is the efficiency model, how is the DC hub efficiency compared with conventional solutions? Both the mechanical solutions and also the diesel electric ones.
Well, actually, the efficiency will increase if you're comparing it with a diesel electric solution, because it's easier to convert the energy if you have a DC hub. If you look at pure mechanical solutions, and then back to where they are operated, if it's going long distances, deep sea voyage, going from Europe to Asia or Europe to America, the efficiency in my mind is best with mechanical solutions. Mm-hmm. So you need to look at the vessels, as you said. Really agree on that. You need to look at the vessel. You need to look at the type to see where does it fit. But for vessels with a lot of maneuvering, cruise, yeah, I think a DC hub could be a really good solution for that, especially for small cruise.
Sure. Yeah.
Super yacht, yeah.
And a question coming in from Martin Eriksson Borg. What is the largest installed power for a direct-driven electrical propulsion machine you've to date supplied?
Oh,
do you have that figure?
It's a very, very good question. We have solutions for 15 megawatt. So we can do 15 megawatt direct in line. Largest one we have installed. No, I'm sorry, I don't remember what's the actual number there. What we have installed.
Okay, no worries. And when you're going for an MV solution, it's usually to reduce the short circuit current in the installation. But how can a DC solution, which is even worse, to break a current, and replace such an MV solution?
Well, the most important thing here is the energy. How much energy do you transfer into a short circuit? And when you have our electronic bus link, they detect a short circuit so fast. So while the current is rising, they will detect it and disconnect it. So you don't get that much energy transferred. If you have a medium voltage solution, standard solution, you can have a problem with short circuits, and then you need to go higher up in voltage. If you have a low voltage, it can be a challenge sometimes to find the correct configuration to make sure that you don't come so high in a short circuit that you have a problem with the equipment that you are installing. But with a DC hub and electronic bus link, it's not any problem.
Okay, thank you very much. Great, so let's move on to Dr. Lars Greitsch, Managing Director, Head of Research Innovation, MMG. Dr. Greitsch started his professional career after the A-levels with an apprenticeship as a car technician. After that, he studied mechanical engineering and naval architecture at the University of Rostock, finishing with a degree diploma engineer in 2005. Up to 2009, he worked at the Institute of Ship Design and Ship Safety as a researcher and wrote the dissertation on the topic development design tool for shipwrights based on statistical operational data. Following his academic career, he moved to MMG in the first place as propeller designer, later as head of research and innovation, and since the beginning of 2017 as managing director. His main topic of work was the development of the MMG redesign program, where up to now 320 retrofit propellers were designed and produced based on the evaluation of operational data. So over to you, Dr. Greitsch.
Yeah, thank you very much. I hope my presentation is visible. Also, warm welcome from my side. Topic is the digital twin. I will explain why this is so important for modern ship propeller design and manufacturing. But first of all, some words to MMG. So we are well known as a propeller manufacturer. Since long time, we manufacture propellers for large merchant vessels for the Asian market and of course the European market. But we are as well very experienced in propeller design and use a lot of modern tools, which I will explain in the following slides a little bit more in detail. We are located in Germany, somewhere between Berlin and Hamburg, we used to say. And our market segments are mainly container vessels, but as well bulk carriers, oil tankers. LNG tankers is of course an upcoming market, but we are also involved in cruise and yacht market, so let us say the premium sector, and nevertheless Navy and research vessels. Coming to the topic of modern propeller design, everybody is aware that we are have to work in a challenging design scenario. We heard it in some other presentations today so far, that we have to be aware that we have to cover a lot of operating situations. That is, of course, made by data preparation, data analysts, but so far a lot of naval architecture projects are based on a very artificial testing scenario. I think everybody knows the more or less simplified testing conditions. We put a lot of effort on increasing measuring accuracy, but do not cover all the broad bench of operating scenarios, which we have to fulfill later on in full scale. That lead us to a problem that we have to cover a lot of influences on the propeller design, not only the well-known influences as the interactions between propeller and hull, but this is of course not in any case covered by classical design approaches, but more or less the customers are more focused on speed profiles, operational matrices, operational scenarios, and nevertheless we already heard some information today, of course, post and pre-swirl devices and so on. And the task is at least to increase the overall efficiency for these projects, not only in the new building cases, but upcoming in the so-called retrofit cases, where I will give some more information later on. And of course, for the propeller, it is driven normally by a combustion engine, and we all know that we have a limited characteristic diagram of the engine, and we have, in the case of a fixed pitch propeller, we have a rigid link between propeller and main engine, and that is very important to understand, that we have to be careful with all the influences, all the accuracies in design and manufacturing processes to meet the best adaptation of propeller to the main engine. That led us to introducing more or less 5 technologies, but today I will only talk about 3 main technologies. The first I do not mention here is the case how to involve data or operational matrices in the pre-design phase, but today I will start here with our numerical propulsion simulation, because it's a question, how precise can we predict the hydrodynamic behavior of a propeller? That is, of course, very important to meet single points, but as well the broadband requirements from the ship owners. Then, of course, data quality in our manufacturing process. That is very important, that all design informations will reach the CNC machines as well. I will not focus too much on that, but which is, of course, very important for the final product to prove the geometry, the foil geometry of a propeller by advanced checking methods. We use here complete surface scans with optical measurement systems. But today the topic is performance, and that is, of course, mainly driven by the hydrodynamic design process. We introduced the CFD methods a long time ago and increase the coverage of all design aspects over the year, so that we use the advanced runs CFD during the design process. And you see in the pictures, of course, we cover as well some special topics as control rotating propellers, powered drive units, but of course as well our main sector, the fixed pitch propeller. That, of course, in the design process covers, of course, hull resistance calculations. Today it was mentioned that, of course, air lubrication systems are also in the development and application. This can be also considered in these design steps. Then the classical things like propeller open water behavior, but this is nowadays again a topic because the propeller geometry changes a lot and towards smaller areas, for example, and that led us to lead to a problem in in model testing again. And so we, in the propeller developments network, we face again the problem of scaling effects. So the question, if we calculate in a smaller model scale, then how is the behavior at in the final scale, in the full scale scenario? That, of course, is also related to propulsion and speed power behavior, and the most complicated case, cavitation and noise prediction. Cavitation, of course, is the standard requirement, but noise can be also for the merchant vessel a future requirement. Here an example that also sea trial prognosis can be made in a very precise way. That is a real case. It was a blind case from a retrofit project. In that case, I think it was 8,000 TU, and we were asked to make a full-scale prediction with a retrofit propeller, so without any indications from testing. And of course, in these trimmed hull condition, and the prediction, accuracy is enormous. Why can we achieve such kind of good prediction quality? That is at least the result of long-term experience and consequent validation with full scale, not only CFD versus model test, because there we know that we have a lot of influences from the measurement accuracy and also the scale effects. We make consequent validation with full-scale data from the operating vessels that, of course, needs a data filtering, because in reality we have to handle average data with some, I don't know, in any case, some non-physical data triples. In propeller design, we of course look at the data triple, RPM, vessel speed, and main engine power. And of course, due to the data handling on board, there are in any case data points which would lead us to a wrong interpretation of the data. That was the case that we at MMG firstly developed a smart filtering method. It is at the first step according to ISO 19030, but at the end, in the final step, it's a physical data filter considering the propeller physics and its boundaries, so that we, and that is here given in the right picture, we can filter out the vessel's data down to a reliable data set, and that can be then in a second step filtered down to different operating scenarios, and that gives us the link to our CFD calculations in a very precise way, so that we can enhance our prediction methods based on this real-time data. Here at the lower end, you see now the second step, then down to a certain operating cases, and that of course gives our engineers a good picture how far we are or how close we are to the real data response from the vessels with our predictions. If we do so and have designed the propeller in that holistic way, then of course we do everything to ensure a good manufacturing accuracy. I said I do not want to focus too much on that, but here we use a lot of advanced technologies as surface marking robots, and at the end the optical surface scan. And that of course, in case we, for example, for the new building projects, we are asked to make a model test, that of course starts with the model propeller. For the topic of model testing, the model propeller geometry and the accuracy of it is a very, very important topic to make sure that at this point the first inaccuracies can be avoided, and so we have a very consequent use of these optical scan methods. But today, in the first presentation, we had a good overview about the upcoming regulations. I have to say that MMG did the first propeller retrofits in the year 2013, so long time before these new regulations for the existing vessels come up. But the basic idea was the same in the year 2013, so that the container fleet at least was forced down to slow down the vessel speed by the markets, and in that time as well for the because of the fuel prices. Now we have regulations, but the solution is the same. We have to find the new propeller for this scenario. And of course now, because of these questions of EEXI analysis, we enhanced our service proposal also to these pre-calculations, then of course introducing the numerical propulsion simulations for checking operating conditions and the possibility and the potential of a good propeller retrofit. And then of course we would apply a propeller retrofit, maybe as well with a fin cap from MNG, so that we can give a solution out of the pressure that is coming up from the EEXI regulations. A bit of view from the past so far. It was told in the introduction. So far, we applied more than 300 retrofit propellers. You see here small analysis in what kind of container vessel size classes these retrofits took place. You see more or less all sizes were covered. Of course, the ship owner started with the more or less larger vessels, but we see from the market that a lot of smaller vessels wanted to be retrofitted as well. So the market is coming up, and we are prepared for our customers to give the best solution for that. Small view on how distributed our applications are. Maybe some smaller projects are missing, but this is like a reference overview about all these possible applications. Please check our website for that. We prepared some good information for the EEXI topic. If you check up EEXI at Google, you will find us. So I'm very happy to present you this here. Thank you very much for the attention, and I'm prepared for your questions.
Okay, thank you very much, Dr. Greitsch. And I've seen a few written Q&A that's come in for yourself. I don't know whether you want to take these questions now or wait for the end, because you didn't have a slot for the Q&A, but if it's easier, we can do it now.
Yeah, of course, we can do it.
Yes. First of all, they're asking Chirag Christina what software was used for the CFD simulations.
We have different software in-house from ANSYS and Numeka, for example, as well some open codes. So more or less for research projects, but of course we have also for the pre-calculations and data preparations, we have a lot of in-house code that we developed over the years.
Okay, and a couple of questions from Brian Bayliss. Does the variable pitch help or not? And is a twin screw better for propulsion? These are more general questions.
So variable pitch means not a fixed pitch propeller, but a
CPP.
Yeah, but this is more or less not the question here for the efficiency reasons. Of course, we have it today. The maneuvering aspect is for that question the more important question. A CPP in general cannot give the same efficiency as a fixed pitch propeller for the design condition. And if we analyze the data of these vessel configurations, and the fixed pitch propeller is very capable to follow these operating conditions, so that is not the point. And if you would use a CPP in off-design conditions, then of course the efficiency will decrease. So the CPP is really focused more on the maneuvering aspects as for the efficiency aspect, and we see a market in the trend towards more diesel electric driven trains. So that could give you the answer that if it's possible to drive for the maneuvering aspect the fixed pitch propeller by diesel electric trains, then it's in principle the better solution. And the other question was the twin screw question. That is, of course, for the merchant vessels, a question which one shipping line tried to answer for the very large container vessels. It was the Maersk 19,000 TEU vessels, which were designed as a twin screw. The question is that only from the hydrodynamic aspect, there could be an advantage if the design is perfectly aligned, because the thrust loading on the propellers, on the both propellers, is lower than for one propeller. But you do not have to forget that you distribute, that you have to need two smaller engines compared to one larger engine, and then you will lose a lot of benefits in the efficiency of the engine itself. And of course, you have some additional costs for maintenance. You need two engine rooms, etc. There are only some vessels in the merchant fleets, that is namely the LNG carriers, who normally have twin screw, but this is more or less a requirement from redundancy, not so much from the efficiency aspect. And the gap is very narrow between a well-designed single screw container vessel to these twin screw vessels, from our experience.
Okay, and another question is that you, I think, were mainly mentioning container ships, and whether you've applied such, let's say, MMG redesign for other types of ships, like bulk carriers.
Yes, we did so far, also for tankers and bulk carriers. But the main reason why the topic was more pronounced for the container vessels is that the engine power is a big influence. So if you go with the older container vessel designs, if you slow down your top speed and can cut off engine power, so engine power limitation, that is exactly that what the EEXI now requires. Then from this difference between the original power and the new specified maximum power of the vessel, this difference, this gives you the freedom for the propeller design. And it's obvious that if you look for the segment of tankers and bulk carriers, then also in the original design configuration, the engine power is not so on that high level as for the container vessels. The vessels are in the original conditions, the vessels with the lower top speed. But nevertheless, we had these cases, and they are more or less different influence is more important. So if you have such a small engine, but from the hull dimensions, a quite large vessel, then the risk that the adaptation of the fixed pitch propeller to the main engine is not perfectly give you, for example, heavy running problems. Heavy running problems could be a safety issue for the acceleration behavior, but as I explained in the, I don't know, 5th slide, if the alignment of the propeller curve and the main engine characteristic diagram is not perfect, then you have all the time overconsumption. You are not the propeller operates not in the optimum of the main engine. And this gives in this vessel types often a motivation for retrofit. Especially if pre-swirl devices are applied for this kind of vessels, which is very often the case, but this influences the light running margin normally in a negative way. And then, of course, a readaptation of the propeller to the main engine gives you additional fuel savings.
Okay, thank you for those answers. I think we have a few more, but we can take those at the end. And I think we can move on now to our final presenter, Mr. Nicholas Van Horis, Chief Technical Officer for Capital Ship Management Corporation, who will be covering energy efficiency innovation portfolio for new buildings. Nicholas is a Newcastle University Marine Technologist graduate with postgraduate studies in international trade law from Northumbria University. strong classification and maritime operations professional with 10 years new construction experience in Korea, with tankers, LNGs, containers, and was also the business manager for Lloyd's Register in Piraeus. Ex-seafarer with shore-based experience in technical department, and as we said, currently is the Chief Technical Officer in Capital Ship Management. Nicholas, over to you.
Thank you very much, Mr. Poulovassilis. Let me share my screen. Okay, I am the last and the most of the previous speakers have touched a lot about this subject, so I will go fast and focus more on the portfolio for new buildings. Just one slide regarding the past. As you know, in the past, the economics, the technology, the infrastructure developments, economies of scales, they have played a role in design efficiency. Nowadays, as you said, Mr. Poulovassilis and Mr. Panos, we have also the environmental regulations pushing for more efficient ships. The IMO strategy was a lot discussed by the previous speakers. I just want to add that EU is also working on ETS, and this is something that we have to note for the future. And on top of that, there are other groups also, financials and majors, expected to launch more stringent requirements for greenhouse gas emission reductions. The EEXI and the CII, it was a lot discussed. What I want to say here is that, as you know, well, for new buildings, EEDI is the KPI, but these days, since EEXI is only 1.5 years ahead, when we are ordering a ship, we actually have to order a ship that has to comply with EEXI from now, because we cannot afford to take delivery of a vessel next year and not compliant with EEXI. And this is where everything becomes more interesting. So when we talk about solutions, we have to take a holistic approach to examine as much as possible. For the new buildings, as I said, less design constraints than existing ships, future-proof solutions, since the vessels will have a very long life. For existing vessels, I think it was already touched by the previous speakers, many solutions in the market. What is very important to note, and it was also addressed by the previous speakers, is the safety and the reliability are the key factors for the solutions, since we're talking about ships. And as you know, ships run remote. These are the models that were touched by Mr. Panos a lot before. I will not spend time here. I will go straight to some examples of what you can find in the market when you are talking with shipyards. Alternative fuels, LNGs. This is an example of an LNG project, concept project. Alternative fuels also, alternative technologies can be batteries, can be solar and sail. This is a very good example of OCEANKING. Rotor sails with ANNEX on an MR tanker, very good expected fuel savings at high speeds and also at the low speeds. Of course, this is depending on the trading of the vessel. This is an example of lubrication. There is potential for improving the ADI up to 2%. Sub-generators, depending on the size of the vessel, 2% in the ADI reduction. This is an example from a Korean shipyard. The bow shield developed by more than one Korean shipyard. It can provide an assistance to propulsion 2-3%. This is a full spade rudder, as discussed before. Here is 2% efficiency for MR tanker. Of course, full spade rudders have been used for various designs, but now also for smaller ships are becoming attractive energy efficiency solutions. Now, this is an example of air lubrication from a Korean shipyard again. Net propulsion savings up to 4% for big container ships. This is another interesting solution for containers, a side gap protector arrangement. It works depending again on the sailing pattern of the vessels, and it can provide up to 2 or 4% energy saving. Batteries have been touched a little bit before. For big ships, we don't have yet many applications, but there are concepts. And there are developments in the technology, depending on the type of the vessel. Shuttle tankers or smaller ships with frequent calls, they seem to be promising. This is a bulk carrier design, a Chinese MARIC, and you can see the dramatic reduction in EDI with the use of LNG as fuel. And concluding, not every solution is applicable to every vessel. It was discussed also previously. There are potential risks when you go to these investments, also technical and operational. There are, of course, technical and operational measures required and solutions with high capex. And this is the end. Thank you.
Lest we forget, huh? Yeah. Thank you, Nicholas. I wanted to ask you, because I know you've had a very extensive new building program and different ship types involved as well. Clearly the EDI, the attainment is one thing, but in service, do you have actual data now showing the effects and the actual, let's say, impact of the different types of devices on fuel efficiency, on energy efficiency? And if so, what is it looking like? Yeah, for the ships that you had designed and you placed the different new buildings and you had the features, have you had actual data in service that you could actually validate those initial decisions?
Yeah, actually, it's very interesting because some projects that we are working very recently, they have achieved phase 3 compliance. That means that they comply with EEXI, actually by using energy efficiency devices. So it is proven that they are working. But they have to be selected very carefully by the shipyard.
Sure. I mean, it goes without saying, but I think this goes for all the issues covered and the various presentations. It's something that has to be validated with actual data in service, and that's always the difficult part. Having access to the right data and then feeding it back into your evaluation and design iteration for the next, let's say, series of ships. Okay, so how do you want to do this? I mean, we still have some time left over. We've got, I would say, another half hour at least to look at the outstanding questions. So I would propose that we can look at some of the questions left over from the initial stage, and then as other ones come up, we can address those as well in turn. So, what I wanted to go back is to Mr. Theodossopoulos, because when I did my introduction, I talked about the first mega trend for shipping, which is decarbonization, but of course we have the digitalization mega trend as well. And Mr. Theodossopoulos touched on both, and indeed the synergies between those two disruptive, I would say, mega trends. So, looking at the specific digitalization technologies that you mentioned, apart from optimizing fuel consumption and minimizing emissions, what other benefits are there to be, let's say, achieved?
Yes, thank you, Apostolos. That's a very interesting question. In fact, before I answer that particular question, I'd like to also touch upon the synergy between the two, or if you like, the usage that monitoring technologies like high-frequency data, digitalization can also assist in assessing investments in capex that, for instance, Mr. Vaporis mentioned before that they're doing in some of their fleets. So, it doesn't make sense to actually spend a lot of money investing, especially in capex, without knowing what the outcome is. And one reliable way of knowing in operation what the outcome is by monitoring, through high-frequency data collection, all these various parameters that affect the energy efficiency of the vessel. But to go back to your question, in fact, it reminds me of a discussion that I had some years ago with the chief operating officer of one of the biggest Greek-owned container ship companies, when he was telling me that his number one concern is for his vessels to be operating, and his number two concern was for them to be operating in the most efficient way. So he was actually referring to the fact that, downtime is not an option. So along these lines, and to answer your question, I think digitalization technologies, apart from the optimization of operations and the consequent energy efficiency, emission reduction, and what have you, with operational measures, I think, especially when it comes to machinery and equipment, the fact that we can possibly avoid downtime, increase safety, save man hours from the crew, either in monitoring or in maintaining or in reactive fixing equipment, it is also a big additional plus side benefit, if you like, for these digitalization technologies. And frankly, personally, I believe that the next wave of application of digital technologies will actually come in the direction of condition-based maintenance and not just energy efficiency. So I think this is, something we'll be seeing more and more in, in mechanical components having a digital twin or a digital, monitoring system next to them attached.
Yeah, and I think this is something which is going to be, it's definitely the trend that we're going to be discussing a bit more about digitalization and specifically the impact on performance monitoring tomorrow in the respective module. So I don't want to touch too much upon that topic. However, it is interesting to see the synergies, as you mentioned. A couple of questions came in just now for Capital, for Mr. Vaporis. I think first one probably is a repeat of the one I asked you. Which energy saving devices did you apply yourselves, and what are the real savings of them? And the second is, what are the combination of energy saving devices you see in the new construction vessels in Korea and China? I don't know if you have a view on that, Nicholas. Differences between Korea and China.
Yes. Okay. Well, from what I saw you there, these are solutions offered by the shipyards, depending on the type of the vessel. For LNG, for example, and Capital was one of the first companies building LNG ships delivered from Hyundai with air lubrication. Okay, that's very famous one. The full spade rudders are applied now on all types of tankers. It was not the case some years ago. It started with VLCCs and gradually came down to Suezmaxes, Aframaxes, and now also applied on MR tankers. And believe me, it makes a good contribution to energy efficiency, even though it is considered something, you know, long years in the market. It was not used in all ship types. What else? Okay, all these fins before or after the propeller, twisted rudders, VFDs are becoming very famous. We apply VFDs. We are fans of LED lighting. We apply LED lighting for all our new buildings. LED lighting in the past couple of years, they have become attractive to many owners ordering, especially in Korea. And their prices actually they have come down. There is a lot of competition now, so you can buy LED lights not as expensive as 3 years ago. VFDs for your pumps. Very interesting concept for big containers, since we have a big portfolio of containers, are the savings from the ventilation of the cargo holds. There is a very interesting concept to look at applying VFDs or multi-stage, two-stage ventilation of big containers in the hold. As you know, these are monster ships and they have many kilowatts of fans. But some ideas that we are using. We are examining our rotor sails, as I said. AMPs on tankers. I think we are also going to pioneer there.
Okay, I think that gives a good, let's say, portfolio of different options that you're applying.
A lot of options.
Yeah. I have a question for Dr. Greitsch, actually, which I wanted to ask, because this is something which I think he's always concerned us, looking at, let's say, any redesign or retrofitting, because you mentioned the use of CFD, you mentioned the model tests, and then also validating with full-scale data, and then providing this iteration loop. But what happens with actual, let's say, in-service data, and looking as well, what are the reference data assumptions, in accordance with ISO standards that you can apply? Is that in practice something that you have access to and you can put it back into your processes?
Yes, as I explained, for a lot of projects, we collect the data, of course, always in cooperation with the ship owner. Could be such kind of modern, continuously we collect the data, or the classical noon reports. At least for us, it doesn't matter. The important thing is that the data quality is good, and that's the reason why we applied some filters. The example was, of course, that we can apply the ISO rules in these ISO 19030, but this is maybe not. There we are not at the end, because this is only a checking of mathematical data quality, but not a check whether the data, for example, the average data, if we focus new reports or continuously collected data, which are also averaged, because the data handling is very complicated. If we have, for example, a data set per second, that is in practice not the case. So in any way, there's an averaging. That is maybe not a problem, but if we have operating situation where the averaging would lead to the case that the main engine power and the propeller RPM and the vessel speed does not fit to any hydrodynamics of physical rules, then of course this data set is useless for us. Maybe not for other checkings and analyzers, but we have to know only valid data which fits to the propeller physics. And there we applied a very capable filter on that. So that leads to a data reduction dramatically. I have an example in my head that we started with, for example, 11,000 data points for the container vessels operating, I don't know, half a year or something. And then we filtered out, first of all, the normal quality checking. Then we filtered out certain operating conditions, like a small range of draft. So let us say looking for one draft and trim condition. And then we check these data according to the propeller physics. And at least there was left 7 or 10 data points, but these data points, they are fully on a propulsion curve, fully in line with the calculations, and that is the success for that. So the link to your prediction, and of course with and based on propeller physics, that is very important.
Okay, that's very reassuring.
Not the amount of data, but at least the quality from the engineers.
Yeah, absolutely. I agree with you. Okay, thank you for that. And I'd like to go back to Mr. Halsebakke as well for, I think, a question that I'd like to ask. Specifically using let's say the permanent magnet machines. What is your experience on this? I mean, how many have you applied, and what are the actual benefits that you think can be achieved?
Well, we have more than 40 in operation, 40 machines, and the benefit of having a permanent magnet machine, it is higher efficiency. It is higher power factor. That means that you can use your frequency converters and your VFD in a much more efficient way. And it's lower inertia on the line. That is quite often quite beneficial. We have done calculations and compared induction machines with the geared solution and the permanent magnet machines connected to a propeller. And we can actually see that it's in some cases it is even cheaper also with the capex to just get rid of the gear and the induction machine and just go for a permanent magnet machine. So not only are you saving money while you're operating it, so you save money on OPEX, but you're also on capex. So we think it's definitely a good solution. And well, you have talked earlier about saying it's always difficult to be the first one, but I can definitely say that for permanent magnet machines and for drives and for DC hubs, we have proven ourselves. Nobody's going to be the first one there. The first one is already sailing and are happy with the installation. So we are past that point.
That's good to hear. Good to hear. Question coming in from Ionel Patrascu. Hi, Ionel. To what extent are the owners taking the risks in implementing new energy-saving technologies? Well, unfortunately, this is the name of the game, and it is up to the owner. At the end of the day, it's their asset, and they take the risks, and hopefully they can take the rewards as well. But there's been a lot of, let's say, voices in the industry saying that charterers should also take some of this risk. And I would say this is the life old, let's say, debate about who takes the risks and who gets the rewards. But also here, because we're talking about technology, we're talking about new, novel equipment, designs, etc. What happens with the designer, let's say the design office, what happens with the shipyard, and then what happens with the actual manufacturers of the equipment. We see in other industries, automobile, it's a different story. But anyone have a view on this? Any of the panel? I'll open it.
The risk comes with the owner, but as you said very correctly, we are trying to push some of the risk to the charterers.
Yeah, and I think
it is true. We are trying to push the risk to charterers.
I would agree with that perspective, and as I said in my concluding slide, I think both the regulation that is actually coming up, as well as the technology enabling some of these changes, I think will actually help us redefine this relation between owners and charterers. I see them personally. I see them in the future working more closely together, more towards a synergy rather than a competition. And I think technology can be the boat in between them. Merging the two views, the two perspectives in a more transparent way, because inevitably there has to be an increased level of transparency, at least at operational level, let alone perhaps some initial capex decisions that have to be taken by the owner. And I think to some extent regulation, I'm not sure to which extent it's pre-designed like that, but it's certainly catalyzing in that direction.
No, fair comment, Panos. Anyone else? Any other views? We can move on.
I can, speaking from a product supplier, of course, we are always very interested in getting our new technology out to the ship owners, and yes, we are depending on owners taking the risk, but for sure, all owners that have done this, they will know that we are supporting them all the time. We are available 24/7. We don't care if it's Christmas or if it's New Year's. We will be there to support them, because we know that the important thing for the vessels are to keep running. You don't make money if you are waiting for a technician, or if you're waiting for a service engineer, or if you're waiting for parts. The vessel has to keep running. It has to be in operation, and so we know that's very important, and that's always when we have new products. We are always with the old products, of course, also available, but with the new products, we know that we need to have a close cooperation. We need to have contact with the crew on board, so that the crew can call us directly. That's very important, to have short communication lines, so that maybe we can solve something on the phone. Maybe I can log onto my computer, fix the problem while they are at sea. We have done that in the Gulf of Mexico, fixed problems while they were there. So that's a very important thing to know from that. We as a product supplier are there for you as ship owners, and also for the system integrators and for the yards that we are supporting. We have to. But it is important with owners that take the risk, because that's when we develop, that's when we move forward.
Yeah, maybe I will add from our side. So the question, okay, my answer could be our task as a supplier is to minimize the risk. So that is, of course, that any predictions which has to be filled in a business plan, calculating return of investment and so on, must be reliable. In the other case, then of course the owner will have a problem, because at least he took the risk for this application, for example, energy saving device. Then the next point is in the dry dock, when, for example, in our case, the propeller is mounted, then of course we have to minimize the risk that there will be an extent of docking time, etc. So a distortion in question of costs, because that will again give us a negative effect on the business case, at least. But what we learned from a lot of projects in recent days or weeks, that the owners are not alone with the question, because we learned that a lot of charterers, they request for such kind of solutions. And the projects where both parties are discussing this on a good level, these projects are the successful ones, that I have to say. Yeah.
Okay, thank you very much. A few more questions coming in. EEXI, is it more concentrated on CapEx or on OpEx? Well, I would say both. It affects CapEx because if there is any initial investment to be made, or retrofit or whatever, that will be, let's say, a significant investment, but can also have an OpEx effect. So you have to look at both, that's for sure. What about this question that's come in? Why are we all shying away from steam electric propulsion? Any views on that, panel?
Sorry, were you referring to me?
Well, no, I said panel, but you're part of the panel, so. Yeah.
Steam and electrical propulsion. So of course, if we have a look on the overall efficiency, then we have some disadvantages, of course, for steam propulsion, as well as for electrical propulsion. I said it's for some kind of vessels, and that is also presented today or answered so far today, for some kind of vessels, for some kinds of requirements regarding maneuverability. Then of course you can play out the benefits of electric propulsion. But for long distance liners, at least, there's so far no alternative for single big combustion engine. The fuel question is completely different, but I just focus on the efficiency chain from tank to propeller, at least. And I hope that answers the question. So there are losses comparing to these combustion fixed pitch rigid link propeller solution that you have to face. Maybe small answer to the EEXI. So I want to add one topic. It was mentioned a little bit. So EEXI is looking on the technological side. So coming from the requested engine power limitation, then of course there could be some pressure to do something, energy saving devices, maybe to enhance again the top speed. That is right. And the CII is more or less operation, yes, but at least in the CII data we have to submit at least any positive measure you put in, you will have as a benefit also for CII. I think that will join us for the next years a little bit, the question. And we have in our customer network a lot of people who recognize this already, and they would plan to do a little bit more just to fulfill the EEXI, because at least we see the CII in the development, so it's becoming more severe over the years. So if you have the idea to do something, then you should also have a look on the years after 2023, or your docking after 2023.
Good. So I think some of you are already answering the written questions, so I think probably we can summarize at this stage, because I think we've had a very good account of a number of options that are available for owners, for shipyards, designs, etc. to apply. We've had some examples of actual savings achieved, but I think what is becoming very evident is that whether you're looking at EEXI that we've covered or the CII, in fact, compliance is going to need considerable planning. You have to come up with both technical and operational solutions in order to improve, first of all, the emissions performance of vessels, but also achieve other targets which may be imposed by charterers, but also financiers, as we've heard. It should also be pointed out that the targets have been set in order to achieve, first of all, the IMO goals, that is reducing carbon intensity of shipping by 40% by 2030, and therefore solutions are going to be more short to medium term, or in other words, stepping stones for the next, leading into the next generation of vessels and systems that we're going to need in order to meet the 2040 to 2050 targets. So whatever we're looking at now is obviously the middle or interim solution, but some, and of course this is the main and then critical debate, is some are going to be the ones which will actually be the final solution as well. So in view of what we've heard here today, I think we are at a critical stage of decision making for all stakeholders, and I think we've explored to a great extent, with the help of our distinguished panel, some of the possible options, and now we need to decide for ourselves, take into account all the different criteria that we mentioned, both technical, operational, but also then the commercial and financial ones. So it's going to be a difficult decision making, that's for sure, but I'd like to thank everyone, first of all the audience for being with us today, some of the really good questions and strong interaction that we've had. Once more, thanks to the sponsors of the event, OCEANKING Trading, Yaskawa Environmental Energy The Switch, and Mecklenburger Metallguss GmbH, and of course to the BS Group for organizing this event. So from me, thank you again, and we renew our, let's say, discussion in the next panel tomorrow on performance monitoring. Goodbye, and thanks.
Thanks.
Thank you. Bye.
Bye-bye.
Bye.
Bye-bye, everyone.